For our next speaker, Harry Roberts is an independent consultant and web performance engineer. He's helped some of the world's largest organizations with their web performance. He also just celebrated 10 years as an independent consultant. You can help him make it another 10 years if you hire him. He's also a Google developer expert in web technologies and a Google Cloudinary Media Ambassador. I forgot what they changed the name to. It's one of those things. And when he's not hustling, he's riding bikes. Harry, everyone give him a round of applause.
Thank you so much. Thank you. All right, this is a really sort of dense talk, so I'm going to dive in. Not much of an introduction. We are going to be talking today about browser cache. We won't be, because my slides aren't working. Apologies, let me just see what's going on. You getting anything down that end? I'm just not getting anything. Right, okay, sorry about that. So today, we're going to be talking about browser cache, or technically, I suppose, HTTP cache. The browser's got loads of different caches in it. I want to talk about HTTP cache. The reason I want to talk about it is because something I see time and time again is developers sort of misunderstanding and misconfiguring cache. It's actually way more simple than people realize. But I feel because so many browsers, or all browsers have a browser cache, and it's omnipresent, that developers kind of take it for granted. They assume it's always going to be there, and that it's always going to work. The amount of rhetoric I get from developers, I don't care if we've got a 2.5 megabyte bundle, we cache it forever. I look at their headers, I'm like, you don't. So a lot of my work recently has been helping organizations, engineering teams, learn how to set caching headers appropriately and just really, honestly, streamline it and simplify it. I think what we're going to find out is it's way easier than you realized. So quick show of hands, honest show of hands, please. Who thinks, and obviously with a crowd like this is going to be quite a lot of bias, but who thinks they've got a good handle on caching headers and they kind of understand it really well and it's set up pretty... Okay, well, that's less than half, actually, so that is an honest show of hands. Who thinks caching headers are sometimes contradictory, confusing, right? Do you know what? Until early this year, me too. Part of my research for this talk and the work I've been doing with clients has been all about just simplifying the process. And I promise you, it's going to be way easier than you realized. For anyone in the room who didn't put their hand up, is thinking, oh my God, a 45-minute talk about caching sounds so dull. Yes. The slides are already online. If you want to follow along, there'll be certain sort of header snippets, code snippets. If you want to follow along, grab a quick photo of this. The slides have already been published, so you can take a look there. Real brief intro. So I'm Harry. I am a sort of independent web performance consultant, which means I help organizations like these with finding and fixing site speed issues. Now, this is a very immodest slide. This is kind of my highlight reel of my client list. But the nice thing about this talk, it's nice to write your own reviews, isn't it? The nice thing about this talk, the thing you will enjoy, it doesn't matter how big or small you or your website is, every website will benefit from having its caching headers set up properly. So this isn't reserved for the elite or for enterprise. Any site of any size will benefit from this. There's a saying in our industry, and you may have heard it before, the best request is the one that's never made, and it's true. You can completely zero out the network cost of certain requests if you get stuff set up properly. The problem is, and I keep beating this drum, most people aren't doing it properly. So by the end of this talk, you will have a strategy in place to get everything running smoothly. Before we dive right in, I want to get some key concepts sort of discussed and understood. It's going to help if we've all got the same shared knowledge before we start to pick these concepts apart. The first and probably most obvious concept is caching itself, and the sort of sister concept, which is revalidation. Caching is how long can I reuse this file without checking for updates? And this is the key bit, without checking for updates. A big misconception that I see is that developers tend to believe that you can cache a file for a week, but as soon as you update it on the server, the user will get a brand new copy of that file. Not the case. If you tell a browser you can cache a file for a week, and you change it after an hour, you need to accept that your users are going to have that file out of date for 6 days and 23 hours, right? It's on you. So it's the biggest misconception I see is the belief that you can simultaneously have cached content and always the most up to date. It's not possible. Revalidation, on the other hand, is how do I check a file has changed after my cache time limit is up? And that's, again, a really key concept. Only after the cache time limit is up. You have to accept the inevitable fact that for a period, users will probably have somewhat out-of-date content between sort of your release cycle and then the sort of cache expiry header, or the cache control header expiring. If you think about it, caching is a way of preventing a client speaking to a server. So in a sense, cache busting is kind of almost impossible. Caching is a way of stopping a browser talking to a server, so revalidation should not happen while a file is cached. If you're seeing revalidations while a file is cached, you've probably got a bug. Something's misconfigured. You shouldn't expect to see revalidation while a file is considered fresh. That brings me on to fresh and stale, two concepts here. When we talk about files in cache, we split them into two buckets. Fresh is a file that is in browser cache and still within its expiry date. Fresh does not mean it's the most up-to-date version of the file. What fresh means is it's in cache, and as far as the cache is aware, it has the latest version. It might not do. The origin server might have an update, but the cache is blind to that. The cache cannot see it, so it will still consider the file fresh if its expiry is still in date. The flip side is stale, and this is a file that is in cache, but it has passed its expiry date. So this file may not be out of date, but its expiry has been reached. Therefore, we need to revalidate. The key thing I'm trying to impress upon you here is that fresh does not mean most up to date. Fresh simply means the cache thinks it has the latest version of the file. It might not do, but we've told it that it can reuse that file for X amount more time. I've been using the word file quite a lot, and really what I should be saying is request and response. So we're not talking about files necessarily, we're talking about responses. When we talk about sort of caching, we're looking for a request that goes out, a response comes back. We use the word response rather than file because the response might be a 404, which literally means there is no file. So technically, throughout this talk, when I use the word file, what I should be using is response. That brings me on to the next concept, 200 and 304 responses. When we talk about caching, these are pretty much the only two response codes that we care about. 200 is, yes, I fetched a full response. And that could be a response that came all the way from the server, or it could be a response that came from the browser cache. One thing I find quite confusing, and one thing I would like to see, is there is no separate response code for a file that came from browser cache. I'd like to see another 20-something response code that says, we fetched a full file, but not from the network. We fetched it from cache. The only way to proxy this would be like looking at the transferred size of the file to ascertain whether it came from the network or from the cache. A 304 is I checked with the server, and you can reuse the old response. So 304 just says, hey, look, the file went stale. I went back to the server. The server says the one we have in cache is still good to use. And then you kind of renew the usage of that file. So 304 response is we went all the way back to the server with a conditional request because the cache believed the file to be stale. It got to the server, and the server said, yeah, there's no change on this end. Go all the way back to the machine and pop that file back out of cache. That will not return a 200. That will return a 304, a revalidation header. When we look at solving problems, I find it easy just to simply remove them. So the first thing I want to step through, and actually a lot of the content of this section came from our very own Andrew Betts, just down there. He wrote an article for Fastly a few years ago, which he looks at all the redundant and unnecessary HTTP headers that responses tend to carry. So the simplest thing we need to do is just get rid of a bunch of stuff. Pragma. The Pragma header is technically kind of a bug. This should have never happened. This one definitely needs to go. Pragma no cache would be the most common thing you would likely to see if you see a Pragma header at all. And this simply should have never happened. It's not meant to be a response header at all. It's been misused. It mainly exists to fix compatibility with HTTP 1.0, and given that we're on H3 now, this is a header we simply do not need. It should not be used. The spec even says Pragma is not specified for responses and is therefore not a reliable replacement for the cache control header. Pragma as a response header simply should have never happened. If you've got it, remove it, get rid of it. The next header we can get rid of, surprisingly, is expires. We don't need expires headers. You probably see these. These are really common. They're not terrible. The expires header isn't a bad idea. We just have way better options available to us now. An expires header would look like this, and it sets a fixed date, hopefully in the future, at which the browser or the cache should consider this file stale. Problems with the expires header there's two. It's not extensible, so all it does is says when the file expires. We can't extend it with additional directives. But the other problem is, and I don't have a visual for this because I kind of only just thought of it a few days ago. I didn't put it into the slides. This file expires New Year's Day next year, 1st of January. I could put a file live and say, right, this doesn't change very often, so I'm going to expire it in a few months' time. What if I take a few months off work? I don't work on this site, I don't deploy anything. On the 2nd of January, anyone who requests that file now has a date in the past. That file is impossible to cache. That's the key problem with the expires header, is that as soon as you pass that date, a date in the past is effectively a no cache, or no store even. So the expires header, we can replace that now. It is a caching header. It's not harmful, but cache control is better. Cache control has been the preferred method of specifying cache rules since 1997, right? A long, long time. It's also susceptible to clock date mismatches. It doesn't really happen anymore, but if you're like me when you're a teenager and you kept putting your system time back 30 days to keep using Photoshop, keep that free trial going, that would break your caching, right? If you keep changing your system time, it can affect caching the expires header. Even the spec says if there is a cache control header with a max age or smax age, max age directive, then expires is ignored. So if you've got a cache control header with max age, you don't need to remove your expires header. I mean, you might as well do just for the sake of cleanliness. But because it has been superseded, the presence of a max age header will immediately just nullify the expires anyway. The way I would think of it is cache control does everything that expires does and more. They solve more or less the same problem, but cache control has more directives, it's more extensible, it can do more things. The other header we can get rid of, we don't need, is last modified. And this might surprise you. Last modified is very, very common, but it's again susceptible to certain issues and problems, some little gotchas. Last modified simply says, this file last changed on this date. And the browser or the cache can then decide, well, if it last changed then, and we've gone past that now and the expires has been reached, I'll go back to the server and see if it's been changed since. So last modified is a revalidation header. So expires is a caching header, last modified is a revalidation header. Again, it's not harmful, but we've got better options or alternatives in ETag. Date of change, and we'll come back to this later in the talk, the date of creation or change of a file is only a proxy for if the file changed. I'm still running a really old school sort of setup for my website, so I'm using GitHub Pages. GitHub Pages, statically generated. If you change just like a single typo on your homepage with GitHub Pages actions or GitHub Actions will rebuild the entire site. So that one little sort of typo change in your footer on your homepage will generate brand new last modified headers for every single page on the site. So that's kind of a problem with last modified is the data file changed or was written to disk isn't actually a reliable proxy, and it's a proxy at best for if the file changed or not. So last modified is open to false positives. Again, it's not harmful, but we have better options. So on the flip side, headers that we do need, and it's nice to sort of know, or you'll be pleased to find out, we don't need many, we only need 2. To get your caching set up properly, we need a cache control header, which hopefully you've seen before. Cache control private, max age 300, must revalidate. Cache control is the header. Each of the comma delimited things in here are directives, which is what makes cache control extensible. Cache control is a caching header, sorry. It superseded expires 6 years ago, is that? A long, long time ago. These are the rules and conditions around which a cache may or may not store a response. That's the one header we do need. The second header we need is ETag. ETag is a revalidation header, and it can look like this. This is a weak ETag. And basically, this is going to generally be a hash of a file. A weak ETag is generally an ETag that's generated on a hash of the metadata of a file. Think about it like an analogy for thinking about weak and strong ETags. A weak ETag like this is like a book's title. There may be many different authors around the world who've written completely different books that happen to share the same title. That's kind of a weak identifier. The ISBN number of a book identifies that specific book by that specific author, despite its title. It's always going to be a unique identifier. That's how you'd consider a strong ETag. That's the analogy that I use to sort of explain this to people in workshops and clients. A strong ETag, again, is usually going to be a hash of a file. It doesn't have to be, but a strong ETag is usually going to be a checksum of the entire contents of a file. This is a very reliable tell or clue, well, not clue, I guess, a very reliable answer to the question, did this file change? So ETag is a revalidation header. Remember, we've got the 2 concepts of caching and revalidation. We need a cache control header to solve the caching, a revalidation header, which is ETag, to solve revalidation. It's slightly more reliable than last modified. As I discussed, you can get false positives with last modified. If your build system touches every file, last modified wouldn't be a good indicator of freshness. ETag is much less susceptible to these false positives. So if we want to set our caching strategy up, we've got loads of different questions we can sort of ask ourselves to help get the right answer. It's not an interactive quiz. We simply don't have time for that. But what I'm going to do in the next section is I'm going to ask questions. And what I want you to do is just turn to the person next to you and see if you can get the right answer. What we're going to do is we're going to solve our caching headers by looking at different scenarios. If the scenario is X, what header would I need? So that's how this next section is going to work. We should have enough time for it. The question is, can this response be cached at all? If yes, what header would we expect? And if not, what header would we expect? So take a couple of seconds, just chat to the person next to you and see if you get it right. You don't win anything, by the way. But if you think you know the answer to this, show off to the person next to you. There's a lot of silence. We're just not sure. OK, if we can store this response, we'd probably just use something like cache control with a max age. One thing I should say is every single number in these slides is just an example. Don't go copy and pasting anything from my slides. These are just examples for example's sake. Can this response be cached at all? Yes. So you might put a cache control header with a max age of, what's that, an hour, 3,600 seconds. If you can't cache the file, you would simply use cache control no store. So we've introduced two new concepts here. The first concept is max age. This is sort of equivalent to the old expires header. This is basically how long can I store this file for? How long can this file be reused? It's a value in seconds. It's relative, whereas expires is absolute. So the way you should think about this is the expires problem is if I say a file expires on New Year's Day next year, but I don't update the file until sort of February, for that month in between, an expires header would be in the past, which effectively prevents anything from caching it. Because the expires header is relative, there's always going to be another week, another week, another week. You never need to re-emit different headers when you change the file. You can always sort of renew. It's always another week. And that's the benefit of having a relative caching strategy rather than absolute. It's relative to the moment it entered the browser cache, so it's not relative to the date the file was created. What this means is people's copies of a file will all expire at different times. If we all visit the perf.now site on different days next week, we can expect our assets to expire at different times to one another. Also, and it's not in the slides because I've sort of trimmed them down a bit, it's when it first enters a cache is when the sort of max age starts counting down. If you've got a file that left origin and stayed in a CDN for a week, it would then get the CDN should add an age header, which is a time in seconds that tells you how long that file was in the CDN's cache. Then when the file makes it to your browser cache, the browser will subtract age from max age and start counting from, it basically takes into account the CDN time as well. So if you see the age header, and this only really applies to people who are configuring CDNs, age header is a header you would need if you're using a CDN, which of course we all are. So like I said, everything in this slide deck is an example. Please don't copy and paste any facts or figures. They're just examples for the sake of it. I'm not responsible for you getting into caching nightmares. The next directive is no store. No store is a very strong directive that says no cache may store this file or this response at all. That's all you need. People really tend to overcomplicate no caching. Any spec-compliant cache, all it would need is a no store directive to say you may not store a copy of this file. A lot of people go all in, no cache, no store, must revalidate. Technically, these two are redundant. You just need the one in the middle. You just need no store. Any spec-compliant cache will just refuse to store anything with no store. There's talk about allowing back-forward cache to sort of cache no-store responses. It's kind of a hotly debated topic. I don't think it's necessarily the right decision. But certain caches, back-forward cache, there is discussion to allow back-forward cache to store no-store responses. But as far as I'm aware, that's not yet the case. There is discussion around it. Next question. By the way, at some point, these questions get really convoluted because the level of question you have to ask in order to get one of the answers I want to give you, some of these questions get really convoluted. Does this response have to always be perfectly up to date? So at the beginning of the talk, I said that if you cache a file for a week, you should expect it to be in cache for a week, regardless if you've updated it at the origin. You can always expect some out-of-dateness. If you're in a scenario where you cannot accept any out-of-date content, if the file has to always be perfectly up to date, again, just chat to the person next to you nearby. What header would you use if the file has to always be perfectly up to date? OK, this answer, this one, do you know? The answer to this one is a little confusing. No cache, right? No cache doesn't mean you can't cache this file. What it means is you can't go to the cache before revalidating this file. So it's a little confusing. No cache does not mean that you may not cache this file. What no cache says is you can't go straight to browser cache. Always go back to the server. If there is an update, get me it. If not, I can then use a file that came from browser cache. This is a way of guaranteeing the file always has the most up-to-date content and, in certain scenarios, still benefiting from browser cache if the file hasn't changed. If the response doesn't always have to be perfectly up-to-date, think of like an image in a blog post. It doesn't matter if it's not the most up-to-date copy of that image. Again, you would just use a max age with whatever time you desire. I've mentioned a bunch of times that these numbers are just examples for the sake of it. Towards the end of the talk, I've got a little bit of a cheat sheet to help you decide roughly what kind of time spans we should look at for caching headers. But until that point, just treat these as examples for example's sake. The next one, the concept we introduced there was no cache. And again, no cache doesn't mean you can't cache this file. Confusingly, it means you can cache this file, but don't go to the cache for the file before going to the server. So this pattern we had before, where we can reuse a file from browser cache, is now forbidden. We cannot do this anymore. With no cache, this is just not a possible paradigm. This is not a possible pattern. So no cache forbids the browser going straight to cache, always makes a trip to the server, which means it always incurs at least a round trip of latency, which therefore means you might not get much of a performance benefit from your cache unless the file was rather large. Most of the bottleneck on the web is latency bound, and if you have a no cache directive, you're always going to have at least a round trip of latency to the server to revalidate that file. If the file was only a few bytes anyway, there's no real benefit to releasing it from cache. You still incurred a full network round trip of latency. So unless the file is quite large, you won't get much of a performance benefit from caching if you have no cache responses, headers on your responses. Can this response be shared? Can the same file go to many different people? If yes, again, turn to your neighbor, see if you know the answer. Can this response be shared? Can this file be used among many other people, or is this file unique to one specific user? If a file can be used by multiple different customers, users, visitors, think of a style sheet. You wouldn't want every customer to have their own unique style sheet. If you're on a news website, you don't want the image on your news article to be unique to every person. You want to have one image that everyone sees when they visit that page. If you have files that you want everyone to benefit from, you would use the public directive, cache control public, and then complement that with whatever max age you desire. If a file is unique to a user, maybe it contains a logged-in state or some sensitive information, a file is only allowed to be seen by the individual person requesting it, you would use the private directive. Private simply says this file, this response, is only to be used by the cache or the client that requested it. Interestingly, you don't need public at all. This is sufficient. The appearance of a max age directive implies public anyway, and actually public comes with side effects. So public can have some nasty side effects that you might not be aware of. One of them is if you've got a basic HTTP auth, you've got a login, maybe a staging site behind a simple HTTP auth. If you put the public directive on cache control, a logged in state will now start to enter public caches. If you leave public out, I know it's Phil's face, it's terrifying. It's a really weird side effect. If you put a public directive on a response that also carries an authorization header, you would assume that logged in state is unique to the person who had logged in. Public will allow that response to enter shared caches, which is exactly what we don't want to do. So public is implied, and if you actually explicitly put it in there, you will run into side effects that you likely don't want. So I would always just advise leaving public out, because it's implied. If you need private, definitely put that in. So you want many people to have access to the same file, like a style sheet. This exposes cacheability to intermediary caches. For us, we're mainly talking about CDNs there. It's implied by the presence of max age, so it's redundant. Public, sort of diagrammatically, would look like this. You've got a file on origin. Someone requests it. It passes through your CDN. A copy of it stays there. And a copy goes to this person, this person, this person. That file stayed in a shared cache. Private forbids that. Only the requesting client may store the response. It prevents data leakage. It prevents people seeing things they shouldn't see. There was a huge, it was Christmas Day a couple of years ago, or many years ago, Steam. This isn't a style, I don't do any gaming, so this story is like secondhand, but someone was telling me a story about There's a huge rush of traffic to the Steam sort of gaming platform. People want to spend their Christmas money on games, whatever. Don't want to talk to their family on Christmas Day, I get it. Flood of traffic to the Steam servers, so they quickly spun up some caching layers, like we need to get some caching, we need to protect origin, we're getting way more traffic. They inadvertently snuck a public directive into their cache control headers. People were seeing other people's sensitive information, to the tune of tens of thousands of responses. People could see people's logged in states, their account status, their sort of financial credit card information. It was a real big problem. I should have actually added that into the slide. Someone told me about this story about a month ago. But yeah, you need to be really careful with this stuff. So data leakage is definitely can happen if you configure these improperly. So private, diagrammatically, the file will pass through your CDN. It will leave origin, it will pass through your CDN, but it won't stay there this time. That response is going to be unique to every person that requested it. The file never stays in the CDN. Okay, right, told you these questions got a bit convoluted. Can we reuse this response for offline users even if it's out of date? Can we reuse this response for a little bit longer even if it's gone stale? If yes, what would we do? This is an unusual scenario, but basically it exposes a bit of a quirk in HTTP cache. There is a scenario in which even the file that has gone out of date can be released from cache. Even if the max age has been met, the cache can release a stale file in certain conditions. If the file can be reused for a little bit of time, if the user's offline, here's another way of thinking about it. When you're on an airplane, you've got no signal on your phone, but you open your phone, you open your browser, and there's a page still out. It even looks like it reloads, but the page remains on your screen. That's because browsers in an offline state are allowed to release files from cache even if their max age has been met. That explains that phenomenon. When you think, how is that page just refreshed even though I'm completely offline? It's because browsers are allowed to release files from cache even if their max age has been met. So if we are OK with that and we think, well, if we can just reuse this file for a little bit longer after it's gone out of date, just leave it alone. Just put your max age and that's all you need to do. If you think that is completely unacceptable and you never want a file to be reused if it goes out of date, if you always need to make sure that as soon as this file goes stale, we need to go back to the server, you put a must-revalidate header on there. Must-revalidate says to the browser, you cannot use, once that 3,600 seconds has been reached, you may not use this file without going back to the server. The top one exposes an implied behavior in HTTP caching, which says that actually in certain scenarios, browsers can reuse files even if they've gone stale. That scenario is usually a scenario in which the browser can't reach the origin server. So must-revalidate. Caches are permitted to serve stale content unless explicitly told otherwise, for example, if a browser's offline. Must-revalidate prohibits that behavior. The spec says HTTP allows caches to reuse stale content or stale responses when they are disconnected from the origin server. Must-revalidate as a way from preventing that. So if you want to guarantee that no one ever sees anything after it's gone stale, stick a must-revalidate directive in there, and that's how you shield yourself from that. Whew, this is a big one. Can we tolerate slightly out-of-date content, a slightly out-of-date response, while we perform revalidation? Anyone know this is kind of a new one, so if anyone knows what the answer is here, I'll be quite impressed. Anyone got any idea how to solve this one? Can we tolerate slightly out-of-date content while that revalidation happens? I heard a couple of people murmuring it. So basically, we've got a relatively new directive called Stale-while-revalidate. One problem with revalidation, when you're talking about caching, is it is synchronous. You might have a web page that you visited before. There's a CSS file in your browser cache, but the max age has been met. What happens is the browser will say, well, the max age has expired. I need to go back to the server. But because CSS is render blocking, what's going to happen is while the browser goes all the way back to the server and says, hey, is there any updates to this CSS? The user just sees the blank screen. That revalidation is synchronous. Even worse, if the server comes back and says, you could have used that file all along, that synchronicity was completely blocking and for no real reason. So what Stale-revalidate does is it permits a grace period. What we're saying here is, for 600 seconds, you can reuse that stale bit of content, but make sure you're revalidating it in the background. If we don't want this, we would use max age 3,600. We'd use a max age with whatever number. Stale-while-revalidate, again, is fairly modern, fairly recent. It's fairly well supported, though, so definitely recommend using it. I've been working a little with CloudNRE, and for their use case, an image CDN, you can normally tolerate slightly out-of-date imagery, right? Unless you're, well, for most use cases, you could look at an image that's like 10 minutes out of date, right? So Cloudinary, we're about to look at adding Stale-while-revalidate to Cloudinary's image responses because, okay, if the image is stale, we can look at it for another few minutes, right? We can tolerate that for those kind of responses. So Stale-while-revalidate basically forces the revalidation to happen in the background. So this is in any use case where we can sort of make do with even if we know it's out of date, we know it's stale, we can tolerate reusing it for a specified grace period. What this means is we immediately get a 200 response. The file's going to be released from cache. But in the background, we send a conditional request to the server, and the server will respond either with that 200 or 304. It might respond with the 200, which says, yep, you did need a new file after all. Here it is. Take that one out of your cache, the old one, and put the new one in. Or it might come back and say, you could have reused it anyway. I'm glad you did. Do we need to configure browsers and CDNs differently? Do you need different caching rules for your CDN to your browser? Anyone know what we might use in this use case, this scenario? Yep, I heard that down there. If we need to configure our CDNs and browsers differently, we would lean on the S max age. S max age, the S stands for shared, so shared caches. Also, this is really frustrating. It's like the whole referrer problem. There's a hyphen in max age, but there's no hyphen in S max age. It's really annoying. But yeah, you'd use the S max age header to configure a CDN or an intermediary shared cache differently to your end user cache. What we're doing here is saying, well, a user, a visitor to your website, can store a file for an hour. That's 3,600 seconds. A CDN can keep the file for a whole day. That's 86400. If you don't want that, if you just want the same caching rules everywhere, you wouldn't use S max age. You would just fall back to using max age on its own. So S max age, shared max age, with that annoying pesky hyphen problem, answers the question, why would you want to configure your shared and private caches separately anyway? I didn't know the answer to this, and I believe it was Barry Pollard who gave me the answer on Twitter. I couldn't find the Twitter thread. Basically, cache busting is a bit of a myth. If you think about it, cache busting is a myth. We've discussed you can't just until a file gets revalidated, you can't just lean into a browser and say, purge cache. As a side note, you can. There's a clear site data header you could use. But for the most part, purging a user cache is very, very difficult. Cache busting is a bit of a myth. Purging your CDN cache is really easy. You just log into whatever CDN you're using, purge all. You can empty your CDN cache whenever you need. So S max age allows for different layers of caching. Because you can't empty users' cache, you can empty your CDNs, you could clear your own CDN cache every time you deploy. We could have maximum 1 hour old responses for customers, for visitors, but we could avoid coming back to origin until we deploy, or just once, for example, once a day. So the use case here would be the visitor goes back to the CDN every hour. The CDN only goes back to the server, goes back to origin, either daily or whenever we roll a release. This helps you shield origin. It also means that users don't have very, very stale content, mainly or sort of mostly an hour-old content. But every time you roll a release, every time you deploy, you can purge your own CDN cache. That layered caching strategy is really quite elegant. Is the file hashed? Quick show of hands. Whose build system puts fingerprints in their file names? That's not enough. OK, well, get this configured. This is really important, but it also allows us to use some really powerful, aggressive caching strategies. If your build system puts fingerprints or even just version numbers inside your assets, you can cache these things really, really aggressively and basically forever. Cache control max age, and in a 32-bit world, forever is that. That's 68 years, just over. And immutable. Immutable is a relatively new cache control directive that says, this file never, ever changes. This file is immutable. This file is never going to change, so never bother revalidating it. This was sort of developed and worked on by Facebook in, I think, 2015, so it's been around for a while as a concept. If you've got hashed files, you can stick immutable on there, and you can put virtually whatever number you like in the max age field. If not, you'd set a cache control with whatever number you need, but without the immutable. So immutable, like I say, relatively new. It makes a contract with the browser. What immutable does is it tells the browser, this file never changed. If you think about it, a hashed file, if you change it, the hash changes, therefore the file name changes, which means you don't have that concept of that file disappears. Hashed files, their content literally never changes, so they literally never need revalidating. That's the beauty of immutable. It prevents browsers. It makes a contract and says, this is never going to change. Please don't bother coming back to the server. How long is forever? So I looked into this recently, and I wrote a little blog post about it. The spec doesn't actually specify what a forever is. But in a 32-bit world, the biggest sort of number you can store is this. Well, it's stored as 10 and 31 ones. If that was 32 ones, that would be negative 2 billion or trillion or whatever that is. In a 32-bit world, that's the biggest number you can sort of store in binary. Technically, though, the spec says you can pick any number you like. That could be 1,000 nines. There is no maximum value for max age. You can put it as big as you want. What the spec says is any cache should store the biggest number it knows how to store. So if you put 1,000 nines, but the cache can only do 2 years, the cache will do 2 years. The cache should always do whatever the maximum it can do. Ideally, what's been specified in the header, but whatever the maximum it can do is what the spec sort of not permits, but suggests. Back with the expires header, it was the spec said that caches should treat forever as 1 year, and that's why we kind of standardized on that the 1 year caching. Turns out the spec says we can cache things for literally forever. Whew, right, so we've solved caching. We now need to solve revalidation. What do we do after that file's gone out of date? What do we do after that file's gone stale? Technically, quite interestingly, we don't actually need revalidation. What we could do is just be wasteful and say, right, well, this file's max age is expired, so we'll just go back to the origin and re-download the file regardless of if it's changed or not. This would work, but it is wasteful. What you should think of a revalidation as is a renewal. It allows you to continue using a file and just update its caching headers appropriately. But technically, if you think about it, we could just be very wasteful and say, well, this file's expired. I'm not going to bother checking if it's updated. I'm just going to assume it has. I'll re-download it. Then you get lots of false positives and transmit wasted bytes. So yeah, you could always just fetch the whole response without checking if we actually need to. That's not very much in the spirit of web performance. That's quite wasteful, so we shouldn't risk that happening. So revalidation headers, we've got options. We've already discussed we shouldn't really use last modified. It's susceptible to false positives. We should be using ETag. Both of these will cause the browser to emit what we call conditional requests. If you have an ETag or a last modified, the browser will emit a conditional request that says, hey, have you changed? So in this scenario, what would happen is we will get a conditional request to the server. If the file has changed, so if modified since or if non-match, we'll get a 200 response. If not, if it's 304 response, that file comes back from browser cache. Like I say, technically we don't need to do revalidation. We could just always fetch the full update, even if it hasn't changed. But this just avoids being that wasteful. So a conditional request will dispatch a request with a header, like if non-match, if the response had an ETag. If we use last modified, it would dispatch an if modified since. If your build system has both ETags and last modifieds, they'll both get dispatched. And if even one of them matches, even if one of them resolves to true and it has changed since then, it will take that. So even if your ETag hasn't changed, but your last modified has, the browser, the cache will always request the new file. So if you do have both, you can run into conflicts. If it's true and it has changed or it doesn't match the ETag, you'll get a 200 response. Here's your new file. On the flip side, if the file hasn't changed, can be reused, you get that 304 response. We prefer ETag. I mentioned this briefly already, but last modified changes whenever a file is written, even if its content hasn't changed. ETag should be a checksum of the contents of the file, therefore won't change unless the actual contents of the file has been updated. It avoids false positives and wasteful 200 responses. So just to show you an example, this isn't how it works, but as a model, as a little demo, all we've done here is create a file called revalidation that contains the string hello world. We can see its last modified was blah, 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 37 minutes, 50 seconds. The MD5 checksum, what's that, 6F5902. The checksum is that. We rewrote the exact same content into the exact same file. The last modified has updated, but the content hasn't. The hash remains the same. This is the false positive situation you run into if you're relying on last modified. The next thing we're going to move on to, and I've already mentioned this already, but don't revalidate hash responses. Hash responses don't need revalidating. If you've got a fingerprint in the file name, it never needs revalidating, so don't put an ETag on that response in the first place. There's no point attaching revalidation headers to files that we don't even revalidate in the first place. So it won't be sort of troublesome, but there's no point emitting a revalidation header if we've also told the browser not to bother revalidating the file. Because hash files never change, there is no need to revalidate them. All right, so I've got a couple of minutes left just to wrap up. That is a pretty dense talk. There's quite a lot in there. So just to recap, what have we learned? First thing I want you to take away from this is we should not expect to fetch fresh content if a file is still within its fresh period. If we are getting revalidations while a file is considered fresh, we've got a conflict somewhere, we've got a bug. We shouldn't expect to be able to fetch new content while a response is cached. It's the kind of trade-off we make. If we decide to cache a file for a week, we have to admit that that file could be out of date for a week, or 6 days and 23 hours, right? The other thing is, we only have two jobs, caching and revalidating, so we only need two headers. I think the biggest sort of thing we run into when it comes to configuring caching is that there are so many headers available. Which one do we need? Do we need all of them? We've only got two jobs. We only need two headers. That would be cache control and ETag, and technically, if the file is fingerprinted, we don't need the ETag. So in that scenario, we only need one header. Expires, caching headers, and last modified revalidation headers aren't bad, but we do have way better options in the form of cache control and ETag. Files that never change never need to be revalidated. Those are the main takeaways. The whole section in the middle of the talk with the different directives, those fit specific use cases. You can refer back to those in scenarios that match your use case. Really quickly, handy cheat sheets. So just to give you an idea of what kind of time frames we might be looking at for these max age values, and again, these are examples. Think of like never cache a file, cache it for a short amount of time, medium, long, or forever, and you're thinking in like minutes. Can we cache a file for a few minutes? Possibly. So, for example, excuse me, my account, right? User-sensitive information, probably stick a no store on something like that, never cache it. The news homepage for maybe, I don't know, the BBC website, for example, probably cache that for a few minutes, but we don't want to have like yesterday's news. Store locator. If your business is doing well enough that you're opening stores every minute, then well done. But the flip side is pages that don't change very frequently, you can cache those for a matter of hours, then slowly settling to days, weeks, and then the sort of theoretical forever. For non-versioned assets, for assets that don't have versions in their names, that aren't fingerprinted, we need more granular cache control directives to be a bit more specific and precise about what should happen. We would need ETag as a revalidation header. They'll both need cache control, so versioned assets and non-versioned assets both need cache control. Versioned assets, stick immutable on there, tell the cache to keep hold of it forever, and set your maximum expiry, which is, technically it's infinity, but about 68 years. And if you're backing yourself that much, then I applaud you. 68 years is a long time. With that said, I want to say thank you for your time. It was quite, like I said, quite a dense talk. Some further reading, I already cited Andrew Betts' article during the talk, but some good stuff to read there additionally. But yeah, with that said, thank you very much for your time. Well. Question time.
Great job, Harry.
Thank you very much.
There are lots of questions. I hope you're ready.
Oh, really? Okay.
I mean, luckily, you'll be saved by the bell at the end.
Yeah, well, we've got the table up there as well, haven't we?
That's true. I keep forgetting to remind people. In case you forgot, there is a table up there where you can ask questions later to our speakers if your question was not answered. So first off,
right.
What happens if there's more than one cache control header?
Oh, like two cache control headers on the same response?
Yeah.
As with all HTTP headers, a client should sort of concatenate them. Mm-hmm. So what it'll do is it'll take all your different cache controls, put them into one long one, it'll concatenate them, sort of like on the fly. And if you've got conflicting things in there, so let's say you've got a max age of an hour and a max age of a week, a cache should take the smaller of the two. Mm-hmm. So if you've accidentally put cache control a week and then cache control an hour, the browser's going to sort of concatenate those on the fly, and it'll take the more conservative of the two. If you put public and private on there, I don't know what would happen. I presume it would hopefully err on the side of only honoring private,
right?
Hopefully. But yeah, so as with any HTTP response header, they sort of get concatenated, usually set with link. So you usually have like several link, or you usually get loads of cookie headers. Mm-hmm. They all get concatenated anyway. That's just an HTTP header thing. Mm-hmm. Cache control specifically, it'll concatenate it and then pick the most conservative of any conflicting options.
Cool.
All right, that was a long answer to a short question.
No, that's great. I'm sure people are happy with the longer answers. So do you dig into cache rules for every project, or are there particular clues that you watch out for before you start digging in?
That's a really good question. So everyone's favorite tool, web page test. When you run a test, click the repeat view also. And if you look at the repeat view and there's loads of yellow in there, That means there's loads of redirects. That's usually loads of 304s. Lots of yellow means we're doing a lot of revalidation, and can we trim that down? Can we get rid of that? So that's usually my sort of like eyeball kind of just proxying the problem without diving in too far. And then you can, in Chrome's DevTools, you can, in the network panel, you can sort of add a column for response headers, or you could even do like minus has response header cache control. That will show you every file that doesn't carry a cache control header, and you might spot some sort of vulnerabilities there. So yeah, there's quick ways to sort of eyeball the problem. I'm just kind of obsessed with caching at the moment, so I just will always deep dive.
It is pretty amazing. It is one of those hardest problems, right?
Right.
Why would someone choose a weak versus a strong ETag hash?
It's computationally more expensive to generate strong ETags. I don't know to what order of magnitude. I don't know if it's like prohibitive, but you can generate weak ETags much cheaper and quicker. You don't need to know the contents of a file. You can just hash the metadata. So it's just computational expense. But if you're like pre-building your files and you're not doing much like on the fly, you're sort of pre-compiling your assets, then strong ETags would be preferred.
Okay, so for this one, I'm going to say it, but then I'm going to guess what I think the question is.
Okay.
So for Stale-while-revalidate, if the file, like an image, is indeed out of date, will your browser replace the image or only on the next request? If it does replace it, isn't that poor UX? So I think what they're asking is it rendered first with the other image and then switching out, I think.
I believe that's what the question is. I think that sounds right. It wouldn't do. It would be a horrible user experience if it just was like, we've got, especially if it was like a new style sheet, and all of a sudden like the site looks completely different. So it will drop it into HTTP cache as per the new headers, and then the second, it's almost like font display optional, right? There's a risk that the first visit will be complete without the new content, but it shouldn't be harmful to the user experience. Secondary visit to that page should fetch the brand new file from HTTP cache.
Cool. I haven't read all of these yet because there's some new ones that came in. Cool. Is it a good idea to use the file modified time for file cache busting? Although you said it was a myth.
So I think what the question there is, you could fingerprint the file based on its content and put that like a hash in the file name. What you could also do is take the last modified and add that to the file path. But again, if your build system touches every file and they all get the same last modified time, putting that into the file name will still run into sort of false positives. But yeah, the actual fingerprint doesn't need to be like a hash or an MD5 or a checksum of the file's content. It could be a version number. The problem with that is if you like version your entire release and you've got like style.1.2.3, and then you roll a release, you don't make any style changes, but your release is 1.2.4, you're going to get loads of false positives again. So the general idea is if you can use a checksum or a hash of the file, that's the most safe way of sort of guaranteeing the file is or is not changed. But yeah, that file revision doesn't need to be a hash.
Okay, I like this question because it was one of my personal questions too for my website hosting, which I was going to ask Phil later as well. But as a developer that provides services to clients as a freelancer, this is not me, this is Marcel, we deal with hosting and caching systems widely. Should we invest more time investigating if the hosting services we're choosing have proper caching directives on their response headers, if everyone is doing it right? Also, do you recommend testing caching systems locally before putting code to production for ideal configurations?
The first half of that question kind of shouldn't really come from the mouth of a guy who just spent 45 minutes talking about it. I probably wouldn't choose my hosting provider based on their default caching headers. Any sort of web framework or sort of any decent CDN will allow you to configure them anyway. So your hosting provider should be sufficiently capable of allowing you to get in there. I mean, saying that, I'm hosting a GitHub page, and I definitely shouldn't admit this to you all. Don't look at my site's caching headers, please. GitHub pages gives you zero access. So Netlify, for example, is as simple as
that's what I was going to ask. How do I do it on Netlify?
Netlify, you've got a file called _headers, and you can set sort of file paths, wildcards, whatever, and you can set different rules for matching directories or file types, and that's really declarative, and that's really nice. yeah, GitHub doesn't allow that. My site's fronted by Cloudflare, so I could write a worker that strips out the stuff I don't need. And again, a problem with GitHub pages, like I said, is they really don't.
They're trying to be basic because it's really just for.
Yeah, I mean, I can't expect too much from a very, very free tool. But I could just get in there with an edge worker and just strip out headers and do stuff on the edge. The second question was testing these caching strategies locally. Yeah, if you want to wait a year and refresh before every deploy. No, it should be a case of run web page tests against your staging environment or whatever and just check it that way. Checking it locally should always work. It should always work the same. It doesn't really matter if it's coming from localhost or if it's coming from origin or a CDN or your staging environment. Your caching headers, it should be a case of don't check disable cache, refresh and see what happens. You should see it doing the right thing.
Okay, cool. What are some of the most common mistakes that you've encountered?
I've got a client at the moment whose last modified header is 1 second before the Unix epoch. And every file on the web has been modified since 31st of December 1969. That effectively means they've got constant revalidations on all their assets. So that's not a common mistake, it's just quite a funny one. It's usually things like sticking every header on there, not understanding. And I don't blame developers. It's pretty
more
confusing.
Is great.
Yeah.
Better, right?
So erring on the side of doing too much, having too much on too many headers, especially ones that begin to conflict. So those are the most common things. And then a one-size-fits-all approach, I definitely see that a lot. People are like, well, I'll cache my images the same as my style sheets, the same as my script. If you can be bothered to have a bit more granular caching strategy, you can really get quite forensic. These are good questions.
I know, right? There's more. We're not going to get through them all, but one more? Okay, we'll do one more. At a glance, I don't know which one's better. Are there cases when it's faster to fetch a resource over network instead from device disk cache?
Yes. Who asked that?
There's no name on this one.
It's a good question. I don't have it to hand, but Simon Hearn. If you look up Simon Hearn, it's called something like when the network is faster or something. There are instances where fetching a file from the network ends up being faster than fetching it from browser cache.
That's amazing.
Yeah, it is really interesting. It's a great article. So yeah, if you just look up Simon Hearn, when network's faster than cache, you should find an article which details sort of the phenomenon there.
Awesome.
It's uncommon, but it does happen. It can happen.
All right. Well, thank you so much for your talk and your time here. Everyone, give Harry
thank you.
another.
That was great. Thanks, everyone. Cheers.
Cheers.
Thank you.
Thank you.